Happy morning, students. Welcome to Booster 5 Secondary School online classes. So, in this class, we will discuss about Unit 15, carbon and its compounds. So, this is the concept map for the carbon and its units. So, this topic contains in this unit. So, classification. So the carbon and its compounds are classified into two types, that is organic compounds and inorganic compounds. So what are the features of the inorganic compounds? Okay. So next one is catenation, tetravalency, multiple bonds, isomerism, allotropy. Okay. So crystalline forms and diamond graphite fluorescence, amorphous forms, charcoal lamp, black coke, gas, carbon. So the allotropy is classified into crystalline forms and amorphous forms. Okay. So crystalline forms examples are diamond, graphite, fluorescence. Amorphous forms, the example is charcoal, lamp, black coke, gas, carbon. Okay. So next one is plastics. What is meant by plastics? What are the unsafe for the plastics and daily life in our plastics? How to identify the types of plastics, harmful effects of the plastics. So these topics we will discuss about in this unit. Okay. So already we know that carbon is very important for our human life. Okay. So there are million carbon compounds are discovered. So carbon is one of the most important non-metallic elements. Okay. So the carbon comes from the Latin word carbo. Okay. The carbon comes from the Latin word carbo. The carbo means that coal. Okay. So the main constituent of the coal is carbon. So coal is a fossil fuel developed from the prolonged decomposition of the buried plants and animals. Okay. So the earth crust, that is the earth is contains a 0.02 percentage of carbon, that is 320 parts per million by weight. Okay. So it is the form of the carbonates, coal, petroleum. Okay. So 0.02 percentage, and the earth atmosphere 0.03 percentage of contains carbon dioxide. We are inhale the oxygen and exhale the carbon dioxide, but the plants are inhale the carbon dioxide and exhale the oxygen gas. Okay. So the carbon compounds are very important for our human lives because the carbon is present in our bones, muscles, blood, organs, etc. Okay. So in our daily life, the many things are contains carbon compounds. So there is no carbon, there is no possibility for the existence of the plants and animals, including the human beings. So the study of the carbon history is also called as a living chemistry. Okay. So the carbon chemistry is also called as a living chemistry. So first, how to discover the carbon milestones. Okay. So in the ancient times, the peoples known the carbon is a form of soot, charcoal, graphite, and diamonds. So it means soot means sambal. Okay. But at that time, people did not realize this substance were different forms of the same element. After 1772, okay, 1872, Anthony Lavoisier. Anthony Lavoisier and other chemists by a diamond, and the diamond is placed in a closed glass jar. So after that, on the glass jar, the magnifying glass is placed and the sun radiation is through the magnifying glass. Okay, so the diamond is burned and disappear. So the Lavoisier noticed that process. The weight of the jar was unchanged, but the diamond is combined to a oxygen and form a carbon dioxide. So he was conclude that diamond and charcoal were made of the same element, that is carbon. Okay. The Anthony Lavoisier conclude that diamond and charcoal were made up of the same element, that is carbon. Okay. After that, 1779, Carshile. Carshile. So he showed that the graphite also burned to form a carbon dioxide. Okay. So the Carshile is a Swedish scientist. He tell that or showed that the graphite also burned to form a carbon dioxide. So the Anthony Lavoisier diamond and charcoal to combine with the oxygen form a carbon dioxide. So graphite also burned to form a carbon dioxide. Okay. Next, 1796. 1796. Smithson Tennant. Smithson Tennant. So he showed that or established that a diamond is a pure compound, not a compound of carbon. Okay, but the Anthony Lavoisier tells that diamond and charcoal was a compound of or same element, that is carbon. But the Smithson Tennant established diamond was a pure carbon and not a compound of carbon. Okay, so he was burned to form only carbon dioxide. The diamond is only from a carbon dioxide, he tells that. Okay, so the Smithson Tennant proved that the diamonds and charcoal burned, it is give a equal weights of produce the same amount of carbon dioxide. Okay, so next, 1855, Smithson Tennant is a English chemist. Okay, so 1855, Benjamin Brodie. Okay, Benjamin Brodie. He was a English chemist. Pure graphite from carbon, proving graphite is a form of carbon. Although it has been previously attempted without success, in 1955, American scientist Francis Butty and his co-workers at General Electric Company finally demonstrated that graphite could be transformed into diamond at a high temperature and pressure. Okay, so English chemist Benjamin Brodie, pure graphite from the carbon. Okay, graphite is a form of carbon, but it is not exactly proved. After 1955, 1955, American scientist Francis Bundy and their co-workers, that is General Electric Company, finally demonstrated and proved that the graphite is a high temperature and high pressure. It is transformed to diamond. Okay, so graphite transferred to a diamond at a high pressure and high temperature. So this ways the carbon is discovered. Okay, so in same 1985, Robert Kerr, Harry Kroto, and Richard Smalley, okay, discovered the fluorescence. So 1985, Robert Kerr, Harry Kroto, and Richard Smalley discovered fullerenes. Okay, so this is the new form of carbon. So this is arranged in the saucer ball shapes. So the fullerenes is arranged in the saucer ball shapes. So graphene, okay, it is consists of a single layer of carbon atoms, and the graphene is arranged in a hexagons. So when the graphene is discovered, it is officially announced in 2004. Okay, 2004, the graphene is discovered, that was announced. So next, Costoya Novo and Antrijane. They are used to adhesive tape to detach a single layer of atoms from graphite to produce the new allotrope. So if these layers were stacked upon one another, graphite would be the result. Graphene has a thickness of just one atom. Okay, so by 2004, Kostoyanov and Andrei Jain used to adhesive tape. Okay, so these adhesive tapes are attached in a single layer of atoms. So it is a produce a graphite. Okay, so the graphite is a new allotrope. So this is the discovery of carbon milestones. So these are the scientists are one by one discover the carbon and new ones. Okay. So next one is classification of carbon. There are two types of carbon compounds, that is organic carbon compounds and inorganic carbon compounds. First one is organic carbon compounds. So these are the compounds of carbon obtained from living organisms such as plants and animals. So organic compounds only contain a gave a living organisms, that is plants, animals, any animals including human beings. Okay, so from the plants and animals, that is organic carbon compounds. Example, ethanol, cellulose, starch. So these are the examples of the organic carbon compounds. So there are millions of organic compounds in their nature. Okay. So the organic carbon compounds are connected to a other element like hydrogen, oxygen, nitrogen, sulfur, etc. So the organic carbon compounds are depending upon the nature of the elements, and they are connected with the carbon. And the organic carbon compounds are various classes. So that is example for hydrocarbons, alcohol, aldehydes, and ketones, carbonic acid, amino acids, etc. The classes of the organic carbon compounds. Okay, so the organic carbon compounds is totally depending on the nature. The next one is inorganic carbon compounds. So it is opposite to the organic carbon compounds. These are the compounds containing carbon but obtained from the non-living matter. Example, calcium carbonate, carbon monoxide, carbon dioxide. So the inorganic carbon compounds are from the non-living things. Okay. So compared to the organic carbon compounds, the inorganic carbon compounds are limited. Okay. Let's the inorganic carbon compounds. So oxides, carbides, sulfides, cyanides, carbonates, and bicarbonates. So these are the classes of the inorganic carbon compounds. Okay. So how to the formation of inorganic compounds, properties and use of the inorganic carbon compounds we will learn now. Okay. So this is the compounds. These compounds how to form, what are the properties of these compounds, and what are the uses of these carbon compounds. Okay. So already we know that the inorganic compounds made from the non-living things. Okay. So the first one is carbon monoxide. So formation not a natural component of air, mainly added to atmosphere due to incomplete combustion of fuels. Okay, so the carbon monoxide is mainly in a atmosphere, that is combustion of the fuels, incomplete combustion of a fuels, that is incomplete reaction of the fuels to form a carbon monoxide. The properties of carbon monoxide is a colorless, odorless, highly toxic, and freely soluble in water. Okay, so the carbon monoxide is soluble in water. It is very toxic. Okay, it is colorless and no smell. Okay, that is odorless. Okay, what are the uses of carbon monoxide? That is main component of the water and gas. This is the reducing agent. The carbon monoxide is the main part of the water and gas. So next one is carbon dioxide. It is very must for human life. Okay. So occurs in nature as free and combined forms. Combined form is found in minerals like limestones and magnesites, formed by complete combustion of the carbon or coke. So the carbon dioxide, it is in the form of nature. It is a free and combined state. Okay. So combined form is found in the, what is this, like minerals, limestones and magnesite. Okay. It is the complete combustion of carbon and coke. So the rapidly reaction of carbon and coke, the carbon dioxide is formed. It is colorless, odorless, tasteless, stable, highly soluble in water, takes part in photosynthesis. Okay. Already we know that carbon dioxide need for the photosynthesis. Okay. So the property is carbon dioxide is colorless, no color. Okay. Next, odorless, no smells. Okay. Next, tasteless. Next, carbon dioxide is stable. It is soluble in water. So these are the properties of the carbon dioxide. Uses fire extinguishers, preservative for fruits, making bread to manufacture urea, carbonated water, nitrogenous fertilizers, dry ice in refrigerators. So these are the uses of the carbon dioxide. Fire extinguisher. In our schools, we are used in the fire extinguisher. So the carbon dioxide is one of the elements for the fire extinguisher. Okay. So fruit preservative. No spoilage of fruits. The carbon dioxide is used. Making bread. We are eating the bread. So this bread is made for the one of the element is carbon dioxide. And manufacture produce a urea. So the carbon dioxide is one of the element. Okay. So next one is calcium carbide. The formula is CaC2. Okay. Prepared by heating calcium oxide and coke. So calcium carbide is make a heating of the calcium oxide and coke. So when we are heating the calcium oxide and coke, so the property, the color is grayish black solid. Calcium carbide is a grayish black solid. Okay. So what are the uses of calcium carbide? Manufacture graphite and hydrogen to prepare acetylene gas for welding. Okay. So the calcium carbide is used to produce a graphite and hydrogen, and also welding process. This gas is used. Next one is carbon disulfide. So it is directly prepared from carbon and sulfur, and it is properties is colorless, inflammable, highly poisonous gas. Okay, so the carbon disulfide is a very poisonous gas. We are smelling the carbon disulfide, we are dead. Okay, so it is colorless, inflammable. It is not a flammable. Okay, what are the uses of carbon disulfide? Solvent for sulfur to manufacture rayon, fungicide, insecticide. Okay, because it is distract the insect. So it is used in the insecticide, fungicide. Okay. Next one is calcium carbonate, CaCO3. Prepared by pouring carbon dioxide into the solution of slaked lime. So it is prepared by the carbon dioxide solution of a slaked lime. Okay. So what are the properties of calcium carbonate? Crystalline solid, insoluble in water. So calcium carbonate insoluble in water. What are the uses of anticide? Antacid. Okay, antacid. It is used in the antacid. Next one is sodium bicarbonate, NaHCO3, formed by treating sodium hydroxide with carbonic acid. So, combination of the sodium hydroxide and carbonic acid prepared by a sodium bicarbonate. The properties of sodium bicarbonate is a white crystalline substance freely soluble in water. So, the sodium bicarbonate is soluble in water. Preparation of sodium carbonate baking powder antacid. Okay. So, sodium bicarbonate is one of the constituent of the baking powder. Already we know that unit 14. What are the uses of bases? So, sodium bicarbonate is one of the ingredient for the baking powder. So, these are the properties or special features of the inorganic compounds. Okay. Thank you, student.